Happy Monday. Anyone have questions now that it's too late on assignment 1? Okay, that's good. I'm going to practice a psychic reading exercise. My psychic powers are not very strong today, but I'm going to try anyways. The reading I am picking up from the audience is, what about assignment 2? Am I getting the correct signal? Is somebody thinking that? What's your name? Chris, right answer. Extra points. Okay. Not that I need to show the slides right this second. So, I see I've got some, looks like a little bit of Indian on some of the printouts. So please pass. This is assignment 2. So assignment 2, as you can probably imagine, is about volume visualization. A very exciting topic. So assignment 2, volume visualization, volume data conversion and discovery. It's 20% of the module. Therefore, it is recommended that you spend 20 to 25 hours on the assignment, or at least allocate that amount of time. The deadline is the 8th of April at 11 a.m. Problem statements. You are given a selection of 3 volume data sets. 2 of the 3 are unknown and mysterious. Your job is to explore, hypothesize, and discover what phenomena the data sets depict through the use of volume rendering. Rather than producing a volume renderer from scratch, you are to use an existing volume renderer such as the Visualization Toolkit, Voreen, ParaView, Visit, or NVivo to help with your exploration. You are not restricted to the above software. You may use any volume rendering software. There are links to other open source volume renders on the module webpage, and you may also Google others. The tools that you usually encounter are advanced, state-of-the-art volume rendering tools freely available for educational and research purposes. They are open source volume rendering libraries which enable interactive visualization of volumetric datasets with high flexibility. They are implemented as a multi-platform library and so on. In order to accomplish this task, you are to explore the software's features, look for features, with a special focus on their various volume rendering techniques and transfer functions. I have not explained transfer functions yet. So one of the difficult parts of this assignment is just understanding those pieces of volume rendering software. They're non-trivial to use. They're more difficult to use than the general InfoViz tools that you use for assignment 1. They're not as intuitive. So they may require more time to actually understand and familiarize yourself. Since the field of data visualization has not yet evolved to the point of using universal data format standards, the format of the data you have been given will have to be converted to a format that your chosen program can read. The code you write to convert the data follows Bob's concise coding conventions. The input data format for each tool is described on the tool's respective web pages. Mystery data sets. All of the data can be downloaded from the following URL. Currently, there are two phenomena to discover. One is called Sally. Sally is an analytical data set. The other is called Betty. She is a more traditional simulated data set on a regular grid. However, before you start work on unraveling the mystery data sets, start off with rendering a known data set. We recommend you render a known data set supplied by one of the renderers from the list. For example, with Boreen, there is a standard walnut data set that can be downloaded from the following URL. So the idea is once you've chosen a tool to try this with, every tool supplies some data sets. And you just download one of the data sets and try it out before you try to unravel the mystery data sets. Just to make sure you've got it working, the tool that you're using is actually working. If that makes sense. Unraveling the mystery. Your mission is to identify the characteristics of the data and ultimately unravel what they are or what you think they are. Can you use volume rendering to gain an overview of the data? Can you discover any patterns or trends in the data? Does the data have any features at a large scale or a small scale? What do you think the data sets are? What phenomena do the data sets try to capture? Can you support your answers with visualizations that provide evidence? And then there's a list of hints and help there. I won't go through all of the hints and the help there. I will just mention one thing though, because I can't resist. I have already answered 45 questions on assignment 2. Both the questions and answers are on the module playlist called Questions and Answers on Assignment and Data Visualization. Some of the questions are answered in great detail on a whiteboard. So don't be afraid to have a look at that question and answer playlist. Yeah, for this assignment. I got lots and lots of questions last year on this assignment, so I recorded them. And then there is another data set called the Visible Human Project. Has anybody heard of the Visible Human Project before? What's your name?
Nick.
Nick. Where did you hear about the Visible Human?
Graphics.
From graphics. Okay, cool. That's excellent. So the Visible Human is a scientific project where everybody, 2 people volunteered to donate their bodies, their cadavers, to science. And so after they died, their bodies were sliced, and every slice was, a photograph was taken of every slice. Some feedback here, isn't there? It's not very nice. What is that? Does anybody hear that feedback sound? Anybody know where it's coming from? Let's try an experiment.